everyone. In this video, we will work on a real-world application of the simple linear regression model. And so in the previous lecture, Dr. Jiang Min already showed you on the paper how to interpreting the regression output from the Excel. So in this problem, and we're gonna sort of like a summary about what we learned from part 1. And so also learn how can we use Excel to generate the regression output and identify the statistics we needed to answer the regression analysis requirement. And in the lecture, I emphasize for the regression analysis, it's not just about getting a result, but also follow the steps. Starting from getting your regression equation, understanding the relationship between your predicting variable, your x variable, how that help you to understand the variability in your y variable. And then also we learn how to testing the quality of the sample model and how to understand the quality of the population model. And so that is what we're going to practice on. So for this specific question, we are connecting QBE 2000 class with your other business class, which is Principle of Macroeconomics. So in the Principle of Macroeconomics, we learned that the personal consumption are impacted by disposable income. It is totally makes sense. The more money you make, the more likely you're going to spend. So therefore, we are using the real-world data from the Federal Reserve Bank of St. Louis. So they are collecting the U.S. personal consumption expenditure data and also the real disposable personal income data. So given the model we learned from the econ class, we are able to using the real-world data to estimate this equation, so this relationship. So therefore, on this question, I already show you how the equation look like. So the PCE is the personal consumption equal to beta 0, that is considered as automatic consumption, plus beta 1, that is our marginal propensity to consume, right, times the real disposable personal income. So based on the real world data, we will have the value for the y variable PCE and the value for the x variable DSPIC 96. So our main task is to estimate the value for beta 0 and beta 1 so that we are able to know as the disposable income change and how will that impact in U.S. personal consumption expenditure. Okay, so therefore we break down this problem into 6 steps. The first step is identify the regression equation itself and interpreting the result. And the second step is what we call out in our lecture is to measure the quality of the sample model, the goodness of fit. And step 3, 4, and 6. So those are the one we are using to testing the significance of our sample model to see if we are able to use that to representing the population information about United States consumers, right? So therefore 3, 4, and 6, you should receive the same conclusion, but there are different approach we can use to addressing the significance questions. And number 5 is literally just help you to understand where to find SSR, SSE, and SST that we use to form our R-square, right? So this is an overview of the question. Okay, let's starting from question number 1. Regression equation, slope, interpretation, and prediction. So basically the data we already have, let me pull the Excel file. Okay, so this is my Excel file. So when you receive this data, you should be able to see 2 tabs. Sheet 1 is the answer from the regression output, and sheet 2 here is called Fred graph. So that is the raw data we're going to work on today to developing the result you are able to see in sheet 1. Okay, so in order to do that, make sure you have the Excel add-in added to your computers. If this is your first time, under the add-in section, under the data tab, on the right hand side here, you won't be able to see the data analysis. So therefore, you need to follow my step to adding the data analysis to your computer. To do that, click File and move your mouse to the button here called Options. After you select Options, you will be able to see this dialog. If I'm going too fast here, remember you are watching this recorded lecture, so you can pause and go back to look at where did I clicked it. So once I see this Excel options, and on the bottom here, I see there's one option called Add-ins. And click Add-ins. And then going to the bottom here called Manage Excel Add-ins and click Go. So as you can see, currently you see data analysis and the solver because I'm checked this two box. And you should check the box called the analysis toolpath. The other one called the solver add-ins. Please check this two box and then click OK. And then after you do that, now you click the data tab. You should be able to see on the right hand side here, you have seen data analysis and the solver under the analysis sections. If not, there is an arrow here. If you click this arrow, and you should be able to see them. And again, you need to go through this step before you can continue this video. Okay, once you have under the data tab, you are able to see the data analysis tab. And what you can do is you click the data analysis. And here we will choose regression. And once you select regression, and then you click OK. Okay, after you do that, for your input Y range, what you're supposed to do is you come in here. As we already learned, the Y is the consumption, so therefore the Y range will be PCE. So for a student who took my class on regression, I always tell the student make sure including the labels for your columns. So like here, I'm including PCE in my data selection. So this is my Y variable. Okay, after I do that, I finish the selection of my Y range, and I'm starting from B11, including my label, to B704. And for my X variable here is the DCPIC, is disposable income. So first I need to click the mouse to the second box here, make sure that's where I'm gonna select the data. And then I can start to select. Since I include the label for my PCE, my Y variable, I also need to include the label for my disposable income column. Okay, after you do that, and it's scrolling up. Okay, and then you're gonna click labels. Why this is important, I need to check this box because when I select the initial data, I did include the labels. So without selecting this box, you will get error message telling you that there is some non-numeric data included, because if you don't check this box, they will consider PCE and disposable DSPIC 96 as your observation instead of label. So make sure you check it. I also see the other problem. So basically, if some students, they did not including the labels initially, unfortunately they checked the label. In that scenario, they actually end up missing the first observation. So therefore, building a good habit is the key to avoid making careless mistakes. So therefore, the habit here is that every time you do the regression, including the label when you select the data, and also don't forget about check the box called the labels. So after you do that, under the new worksheet here, I want you to name the new tab called the REG, R-E-G. So for this week's attendance check, you will require to submit this Excel file. And when I look at your Excel file, I will looking for if you have this tag called REG, okay, R-E-G. If no, I don't see that, so you're gonna lose the point, okay. And then after that, feel free to check the box residual, standard residual line feed plot, and the normal probability plot. So in this class, we will not using those for residual analysis. However, when you move on to QB 3000, that is where we're gonna go revisit that. So to help you build a good foundation for QB 3000, so therefore I want you to check all 4 boxes here because you're gonna use them when you move on to the QB 3000. After you do auto selections, so double check one more time, compare yours with the Dr. J's video here. Once you did it, and you can click OK. Good. So this is the result you're going to be able to see. Okay. So if you compare this with what I've shown you here, and then you will notice that the REG, let me go back a little bit. So let me shrink it. So you will notice the result from the REG are exactly the same as sheet 1. Okay, so that is how I achieve sheet 1. Okay. Before we start looking at the problem, I want to emphasize that did you notice in the column here, you see E, right? So the E, you will ask, wait, Dr. J, these should be numbers. Why they have an English letter in the cells? So by default, when you see a large digit of number, the Excel will adopt called a scientific notation. So the E here actually means 10 powered by 9. So it's really hard to read. So I highly recommend you to do one setting before you start working on your problem. So you want to set up all your number to keep 4 decimal places, because most of my assignment require you to keep 4 decimal places. So what you need to do is click the top corner here. Okay, after you do that, coming to the main spreadsheet, right click the mouse, going to select format cells. Okay, once you do format cells, and then select number, and then increasing the decimal places to 4. After you do that, and then click OK. Okay, so now the other problem you see is all the pound sound. So every time you see Excel have multiple pound sign, that actually means you did not give enough length of that cell. The number is wider than the length of the cell. What you can do is select the column and stretch it a little bit, and now you are able to see all the numbers. Okay, so based on this output, now we are able to start work on the problems. And let me open a Word document so that I can start typing the answers. Okay, so first of all, as all the Excel problems, the regression problems, the question number A you just saw one is literally just ask for the regression equation, and you need to know how to express it. And the second is how to interpret it. Okay, so let's look at the Excel files. Where can we find information we needed to identify the regression equation? That is coming from this section called the table number 3 of your regression output. Under this table, everything is related to the betas. So the coefficient column here gives us the value for beta 0 and beta 2, beta 0 and beta 1. So the coefficient, the row called intersect, the column called coefficient. So this gives us value for B0, okay, B0. And then the second here, the coefficient intersecting with your x variable's name. So this coefficient value here gives you the value for the slope. Okay, so given that, I'm able to write down the answer for 1. So that means what is the, double check the name I know, PCE, right, PCE. Okay, PCE equal to negative 3422.3582 plus 1.1994, and then this is times the SPIC 96. Okay, so this is my estimated regression equation. And the question number 1 also asks you to also asks you to interpret the slope, the B1. Okay, so interpret economic meaning of the slope coefficient B1. Okay, to interpret that, as we learned in the lecture, if you don't remember, so the slope means if the x variable increased by 1, y variable will change by slope amount. Okay, so before we start interpreting this result, I want to call out the measurement unit here. So all the data here is measured by billions. Okay, billions is a measurement. So therefore, instead of increasing by $1, so if the SPIC 96, so the disposable income increases by 1 billion, we expected the PCE will increase. The reason it's increase because it's a positive value, right? If it's negative value, that means the disposable income increase, the PCE will decrease. So the positive sign means these two variables are moving towards the same direction. So we expect the PCE will increase. The average PCE will increase by 1.14994 billion. Okay, that is question number 1. But the question number 1 also adding a little bit of prediction here. I know in part 2 we'll focus on that, but I still want to calling this out because it is very straightforward here, but you don't want to do the prediction until you test the quality of the model. So therefore we push this to part 2, but here we just briefly introduce it. So now use this equation to predict PCE if the disposable income is $10,000 billion. Okay, $10,000 billion as our disposable income. What are going to be the personal consumption? So to answer that, since the DSPIC 96 equal to 10 billion, right? So we already know the 10,000 billion. We already know the relationship between these two, right? So to answer that question, the PCE will equal to negative 3422.3582 plus 1.14994 times the question is how much? 10,000 billion. So that should give us the answer. So we can use Excel to help us to do the calculation. Okay, let me switch back to my Excel here. So basically that y will equal to the y-intercept plus the slope times 10,000 billion. So that will give us 8,572. So let me just copy this number and I will paste it. So that is how much billion on average we are expecting if our personal personal income, disposable income is 10,000 billion. We are expecting our personal consumption will be 8,572 billion. Okay, so some students are going to ask, hey, Dr. J, does this really make sense? So on average in US, if we increasing our income by 1 billion, why our consumption can increase by 1.14 billion? So are we overspending? The answer is yes. So the reason we are able to get in this this result is because a lot of people are using their future money. Think about yourself. When you have the student loan, you borrow money from your future self to spending now. So therefore, what we see in the US data here, it just means we have a good credit market and the people tend to overspend. So they are not spend with how much they make now. They are spending more than what they make now because they are leveraging the credit system, borrow the money through credit card or borrow money through the loans, etc. to meet their demands now. Therefore, you are seeing this weird result. The disposable income only increased by 1 billion, but our PCE, our personal consumption, will increase more than the 1 billion. Okay, so this is the question number 1.